When most people hear the word bank, they picture a steep river edge collapsing into water. But on a construction site, banks appear almost everywhere. Drainage swales, ditch lines, culvert outlets, retention basins, and freshly graded cut slopes can all function like banks during storm events. Some banks are natural and well-established. Others are recently disturbed and highly unstable. Active banks are constantly changing due to runoff, grading, or equipment activity, while stable banks usually have vegetation, flatter slopes, and stronger soil structure. The construction general permit requires awareness of how disturbed areas interact with stormwater flow paths, and water always looks for the easiest route downhill. The steeper the bank becomes, the more aggressive erosion usually gets, which means steep banks deserve attention long before rain arrives. The steepness of a bank plays a major role in how quickly erosion develops during storm events. As slope angles increase, runoff gains speed and energy, allowing water to cut deeper into exposed soil and carry sediment farther downhill. Steep banks are also more vulnerable to sloughing, undercutting, and sidecast instability, especially after saturation. A slope that appears stable during dry conditions can weaken surprisingly fast once water starts moving through the soil. The construction general permit emphasizes controlling erosion before runoff leaves disturbed areas, and steep slopes are usually high-risk locations requiring additional attention. The steeper the bank, the faster water gains energy, and water with energy immediately becomes everyone's problem. Soil type has a major impact on how banks respond to rainfall, runoff, and construction activity. Sandy soils erode quickly because individual particles separate easily under flowing water. Silts suspend even faster, turning runoff cloudy and allowing sediment to travel long distances downstream. Clay soils can appear solid, stable during dry conditions, but saturation changes everything. Water expands the soil structure, increases weight, and often leads to sloughing or sudden bank failure. In other words, a stable clay bank can suddenly turn into pudding with opinions. Fractured or heavily disturbed soils are even less predictable because water can move through hidden cracks beneath the surface. Understanding soil behavior helps crews recognize which banks are most vulnerable before erosion problems begin. Vegetation is one of the most effective natural defenses against bank erosion. Root systems reinforce soil structure, helping hold banks together during runoff and reducing the likelihood of slope failure. Surface vegetation also slows water velocity before runoff gains enough energy to cut into exposed soil. As water moves through grasses, shrubs, and natural buffers, sediment is filtered and flow becomes less aggressive. The CASCA EC12 guidance specifically emphasizes preserving existing vegetation whenever possible near stream banks and drainage features. Unnecessary clearing removes natural protection and exposes banks directly to rainfall impact and concentrated flow. A healthy vegetated buffer can often stabilize a bank more effectively than people expect. Nature has been managing erosion long before humans started installing fiber rolls everywhere. Heavy equipment operating near banks creates both erosion risks and serious safety hazards. The weight of machinery adds pressure to already unstable soil, while vibration from tracks and tires can weaken bank edges over time. Staging areas, spoil piles, and parked equipment should remain well back from sensitive slopes and drainage channels whenever possible. Loading extra weight near the edge of a bank increases the chance of collapse, especially after rainfall or saturation. A bank that supports equipment perfectly during dry conditions may fail completely once moisture enters the soil. Operators should watch for tension cracks, sloughing, soft ground, or undercut edges before approaching banks. Sometimes the safest decision on site is simply backing the equipment farther away from the problem. Installing BMPs near banks is not just about having controls on site. Placement matters. A poorly positioned BMP can fail quickly once runoff becomes concentrated. Fiber rolls and silt fence should follow the contour of the slope to slow water evenly across the bank instead of funneling flow into one location. Toe protection at the bottom of slopes helps reduce undercutting where runoff gains speed and begins eroding the bank edge. At culvert outlets, channels, and concentrated flow paths, velocity dissipation controls like rock riprap, check dams, and outlet stabilization help absorb the energy before water damages the channel. Perimeter controls should also remain maintained and free of sediment buildup. Because water always finds weak spots eventually, usually faster than everyone hoped. Hazardous materials become especially dangerous when stored near banks, drainage channels, or active runoff pathways. During storms, anything placed on a slope has the potential to move downhill fast. Fuel containers, oils, chemicals, paints, and construction materials should remain properly contained and positioned well back from sensitive drainage features whenever possible. Concrete washout is another major concern near banks. Concrete slurry can rapidly migrate through runoff and create serious water quality problems if washout areas are not lined and contained correctly. Spill kits and secondary containment systems should remain accessible near fueling and material storage areas at all times. Because once chemicals enter a drainage channel, stormwater becomes an extremely efficient delivery system nobody asked for.